Tired of juggling between multiple Excel workbooks just to get your data in the right order? Today, I'll show you how to combine data from multiple files seamlessly using just Excel. Stay tuned and revolutionize the way you handle data. Hello everyone and welcome back for another tutorial. For those of you who don't know me, my name is Linh. I'm a data analyst and automation expert with passion to turn chaos into clarity. And welcome to my channel, where you find plenty of tutorial tips and tricks that help you save hours at work. So make sure that you check them out. If you find these tips helpful, please like and share them with your network. And subscribe to my channel for more insightful tutorials and productivity hacks. In the previous videos, we've helped Excel property, a growing property chain, combine messy timesheet data from multiple Excel tables within a single workbook. Now we're taking it to the next level. Step 4 presents us a new challenge, dealing with external data spread across multiple workbooks. On top of that, critical information is missing completely from the dataset. So today, we're tackling that challenge head-on. We will start by analyzing the current data structure, where to find the missing information and define some data transformation strategy. I'll show you how to import data from multiple Excel workbooks into Power Query, ready for analysis. We will also take some time to understand the underlying mechanics of how Power Queries is able to combine data from multiple worksheets with ease. And finally, we'll perform complex data transformation to extract the missing data which is not originally available in your dataset. Before we start, you can download the data file using the link in the description below. There's also a timeline to help you to navigate through all the sections of the videos. Please feel free to pause, rewind the videos if you need to follow along at your own pace. Ready to level up your data transformation game? Let's get started. What we have here is the timesheet of employees in Store 4. Each timesheet are stored separately in different Excel workbooks. Within each workbook, we have the information of the date, but without the year, the status, including working, holiday, and sickness, the clock in and clock out time corresponding to where the status is working, and it is empty where it is holiday or sickness. And finally, the approved overtime by the store manager. Now, the expected proper data set should look like this. So we're missing the employee ID, the year, and the weekday column. But notice that these missing information is available in the file name. So you have the employee ID here and the year. And based on the year and the date, we can find out the weekday. So for such complex data transformation like this, we're going to use Power Query to help us to perform these data transformation tasks. Alright, let's start by importing data into Power Query. So go to Data, Get Data from File. We're not gonna import a single file. This time, we're going to import data from a folder. So click on From Folder. Now select the folder where your files are located and click on Open. And as you can see here, all the information from the folder is picked up. Since we have a lot of files to be transformed, so I'm going to click on Transform Data. A Power Query window is now opened. It picked up all the metadata from the selected folder. Let's see what we have here. We have the content column, which holds the content for each individual file. Then we have the name of the file and the file extensions. which is the file type, the date information to which the files has been created or modified, some other metadata here, and finally the path, the folders where the files are stored. Now, out of these metadata information, we're only interested in two columns. The first one is the content column, which store the timesheet information that we want. And the second column is the name of the files where we would need to extract the employee ID and the year information. So now we know where the informations are located. How do we extract this information? Well, with the help of Power Query, you can achieve these complex tasks with very little effort. What you need to do is to click on this double arrow down on the right of the content column to combine the files. This will activate the Combine File window. Here you can see the details content for each file within the selected folder. And we have here sheet 1. If you click on this, you can see the content within that sheet. Now, by default, Power Query uses the first file's structure as the sample. Then it will apply the same transformation to the rest of the files within the folder. You can also change the sample files as well. For example, I can click here and choose employee 16 as a sample file. But let's stick with the default option for now. So click on sheet 1 and click OK. As you can see, Power Query has successfully combined all the files from our selected folder for us. So here we have file from employee 15, 16, and 17. So we have all of our data right here in this query. Now the question is, how is that Power Query able to perform such complex data transformation tasks with ease? Well, notice that Power Query has automatically created a bunch of helper query in the query panel right here. And there are also many apply steps that automatically is being created in this apply step panel over here. These helper queries and these apply steps are the backbone engine of Power Query, which help Power Query to perform such complex data transformation tasks. Let's deep dive into the Power Query engine, exploring the logic behind the helper queries and these apply steps. And after that, we'll see the practical example of why it is important to understand the logic of Power Query engine. Let's take a look at the apply steps in our main query. First, Power Query automatically filter out any hidden files within our folders. If you want to apply extra filters, let's say you only want to restrict the data files type as XLSX, you can also do that here in this step as well. Next, Power Query add an extra column called Transform File. This column is the result of the functions transform files over here. I will explain in details how this custom functions works later on. Now, if you click on the blank area, you'll see the preview of the data. This is the underlying data stored in each Excel file. The next step, Power Query go ahead and rename the name columns here and remove all the unnecessary columns. And we're left off with the two final columns, the file name and the underlying data of that file. Now, what's left to do is to simply expand the transform file column to get to the underlying data and append them on top of each other. As you can see here in this step, expand table column. Now, all of these apply steps is possible because of these custom functions that allow Power Query to retrieve the underlying data for each file in the selected folder. So let's shift our focus into these helper query and to understand how this custom functions is created. Let me quickly arrange these helper query in the order of creation. So the sample file should be the first step. Then we have the parameters. Then we have the sample files. And finally, the function. All right, now we have all the helper query in order. Let's explore in details what are the purpose of these helper query. The first query to examine is the sample file, which help Power Query to understand how the underlying data in each file is structured. If you go to the source here, you can see that Power Query will pick up the first file from this list as the default sample. The timesheet of employee number 15, which is an Excel file, and therefore the data type to store this query is binary. Our query will then go ahead and navigate specifically to this sample file, as you can see here. And this is the code that's being automatically generated to navigate to the first files from the list. So right now, the sample files is holding the value of the employee number 15 timesheets. Now the second step, Power Query will create a parameter query. This query acts as a reference that other queries can look up to and understand what is the setting or parameter to use. So right now, it is holding the value of the sample file. And in our case, this is the first Excel file from the lists, which is the employee 15. And using the parameter query allow Power Query to flexibly choose between different Excel files from this list. Next, we have the transform sample file query. If you go to the source, you can see that the transform sample file query references the parameter query, which right now hold temporarily the sample file. And that's why you see all the metadata and the content of the sample file listed here. As the next step, Power Query will navigate to extract the underlying data from this sample file, as you can see here in these steps. So these are the standard data transformation step. And if you want to add more transformation like filters or change data types, you can do so in this step as well. And finally, we have our custom function, transform files. This custom functions is in sync with the transform files query. And you can see the apply step documented in the formula bar here. They are exactly the same steps that we would have seen in the transformation file query. And whenever there are new apply step in the transform files query, it will be reflected in the functions as well. Now this custom functions is then used in the main query to extract the underlying data for each individual file listed here. All right, now that you've understand how the Power Query engine work and how these helper query components interact with each other, let's take a closer look at a practical example. In our main query, we've successfully retrieved and combined the underlying data from each individual files from the selected folder. However, if you look a little bit closer, you will see we have the issue that the column headers is repeated for each file. Here you see it's repeated. So we need to remove the column header whenever it appears in our dataset. It would rather be cumbersome if you're trying to work with this dataset directly. So for example, you would need to promote the first row as the headers. Then you're going to need to filter out the column header and then rename. So there's too many unnecessary steps that could have been avoided with just one single transformation steps. Not here in the main query, but in the transform sample file query. So first I'm going to X all these steps out. So right click in the first query you want to remove and then choose delete until end to remove multiple steps. All right, now go to transform sample file. Right now we have two standard transformation steps, that is going to the source file and navigate it to the underlying data. Now we're going to add a very simple transformation step here, that is to use the first row as the header. And I'm also going to add an index column here as well. So go to add column, index column from 1. So these transformation steps are documented right here in the apply steps. And these are the formula that generates these transformation. And please note that all of these transformation steps at this stage is applying for only one single file, that is the sample file. Now, if we go to the custom functions, we can see that the underlying formula for this custom functions is synchronized with the transform sample file apply steps that we've just completed. And now, thanks to this custom functions, these transformation steps will be passed down into our main query. As you can see here, the column header lines are gone from our data. And another thing to notice is that for our newly added index column, every time we move to a new file, the index column is resetted to 1. While if we added the index column directly from the main query, you will see that the index column will continuously run without being resetted. So depending on your data structure and how you want to transform your data, you have the option to perform the data transformation step in the main query after all the files has been combined, or in the sample file, which applying for only one individual files. And these transformations will be replicated to the rest of the files within the folders. Alright, so now I'm going to remove all the index columns so that we can start with transforming this semi-cleaned dataset into the final proper dataset. Alright, so we're now gonna perform data transformations in the main query when all files are already combined into a single dataset. And I'm going to show you how easy it is to perform these complex data transformation tasks with Power Query. So the first thing we're going to do is to extract the information that we want, like the employee ID and the year, from the source name column. And for this, we're going to split this column into multiple subcolumns. So select the column, go to Transform, Split Column, and Split by Delimiter. Power Query has already identified that the delimiter here is the underscore. You put it there. And we want to split the column each time it appears. So we can have the ID and the year split. And I don't want any quote character. And hit OK. And as you can see, we have the employee ID column splitted and also the year. And for the year information, we only want the year. We do not want the .xlsx here, right? So again, I'm going to transform this information using the extract function. So transform, extracts, and we want the text before the delimiter. And the delimiter here is the dot. So we want the year that is before the dot. So click OK. And now we have extracted the year information. Now we need to combine the year with the date here in order to have the full date, year, and month information. We're gonna need to merge this column. So first select the date column, and then on your keyboard hold the Control key and select the source name 3. Now again go to transform and merge column. Now we're going to specify the merge condition. The separator we want is the slash, and the name of the column will be date. And I'll click OK. And we have the date column as we wanted. Now some cosmetic adjustment to rename the column headers. So this will be employee ID. This one will be date. And we don't need the store ID anymore, so I'm going to delete it. Right, now we're missing one more column that is the week date information, and we can derive that information based on the dates. We can use date and time features, but as you notice, this column is in text format. So that's why all the options in the date and times features here are grayed out. So the first thing you're gonna need to do in order to activate the datetime function is to convert this into the correct data type, which is the date. And so now I'm going to change the data type of the entire data set. Right. So this column has been changed into the date column, and you can see that the date options are activated. But we're not gonna perform the extract of the date name in here because it's going to perform directly on this column. We want as an extra column, so we're gonna use add column and go to date, and now day, choose name of date, and we have the date name columns here. Now the name of the column is not what we want, so you can either change the name as a rename steps, or you could on the formula rename the column headers right here in the formula. So I'm gonna call it weekday. Right now we only need the first 3 letters, right? And we want to perform the extract on this column, so we use transform, extract, and first characters. And we want 3 characters only. And we have all the required information we need for our proper data sets. Only a minor adjustment that needed to be made is we need to organize all the column in the correct order. So simply drag and drop the column in the position that you want. So the employee ID, the date, then it needs to follow by the weekday, status, clock in, clock out time, and the overtime. And finally, I'm going to quickly rename the query. And now we're ready to load this dataset into our Excel's workbook. So close the load to. Now choosing the loading connection as table, existing worksheet, and choose where you want to load your data and hit OK. And we have our data loaded into the sheet. We now have new employees 18 data provided to us. Let's drag and drop this file into the selected folders here and see if our data is updated. So right click and refresh. As you can see, the data from employees number 18 is added as expected. And there we have it, our final proper data set with all the required information available. All the columns are sorted in good orders and correct data type are also assigned properly to each column. I hope you enjoyed today's tutorial. We've seen how Power Query can handle complex data transformation with ease, even when dealing with multiple Excel's workbook. These powerful features allow us to efficiently manage and clean our data, saving us time and reduce error. But remember, we're just scratching the surface of what Power Query can do with its user-friendliness interface. We also went in-depth to explore Power Query features like sample files, parameters, and custom functions. Understand these components and how they interact with each other will help you to solve more complex problems, which we will explore in the next videos. When our data structure becomes even more complex with double column headers, the data that you need is stored in a single cell, and random blank column appears in the dataset. So to tackle such challenge, we'll deep dive into advanced data transformation technique that help you to shape data structure at will. We will also go beyond Power Query interface, deep dive into modifying M code, and creating custom functions that tailor data transformation tasks precisely to your needs. Thank you for joining me on this data adventure. I hope this video has empowered you to handle even more complex data transformation. In case you want to watch other related videos, I'll leave the link in the description box below. Make sure you check them out. If you enjoyed these videos, please give us a thumbs up and subscribe to my channel for more exciting content coming in your way. Thank you for watching, and I'll see you in the next videos.